In this video, you will learn how to find the unknown sides of some special right triangles with acute angles of 30-60 degrees and also 45-45 degrees. Let's first look at a 30-60-90 degree triangle. If I want to look at the most basic 30-60-90 degree triangle, I'm going to take the smallest angle of 30 degrees and make that side length a length of 1. From here, I could use my SOHCAHTOA functions to find the hypotenuse, for instance. If you remember, the hypotenuse is going to be the side directly opposite the right angle. So, if I know using the 30 degrees, opposite side, and I want to find the hypotenuse, we should use the sine function. The sine of theta was the opposite side divided by the hypotenuse. So the sine of 30 degrees would be 1 divided by the hypotenuse. If we solve this now for h, I need to do in my calculator 1 divided by the sine of 30. Remember, anytime you enter something in your calculator, you should check your mode and make sure that the degree symbol is highlighted. So now that I know I'm in the degree mode, I want to do 1 divided by the sine of 30, and that gives me a value of 2. Next, if I wanted to find the adjacent side to 30 degrees, I could either do a different trig function, or since I now know 2 of the 3 sides, I might be more accurate with my Pythagorean theorem. So, if I have 1 squared plus the adjacent side squared, I should get the hypotenuse squared. So basically, 1 plus the adjacent side squared is going to equal to 4. And so the adjacent side squared is 3, meaning when I take the square root of each side, the adjacent side should be the square root of 3. Now that I have my 3 sides for the basic 30, 60, 90, I should be able to use this to find other missing sides in other triangles that have angle measures of 30, 60, and 90. Let's now look at a triangle that has 45, 45, 90 for its angle measures. Again, if I want the most basic one, I'm going to take the smallest angle measure and make the side opposite it a length of 1. Here, because it's 45 degrees and 45 degrees for both of the acute angles, this is an isosceles triangle, meaning that the 2 legs are going to be congruent. And so the other side should also be a length of 1. So here, to figure out my hypotenuse, I can just do Pythagorean theorem. So 1 squared plus 1 squared will equal my hypotenuse squared. And so basically I have 1 plus 1 is equal to the hypotenuse squared. 2 equals the hypotenuse squared. And so the square root of 2 is going to be my hypotenuse. Now that I know these lengths, I can again look at either triangle and make either of the acute angles theta and find the different trig functions of that angle measure. This is what we're going to do to fill in the chart below. So let's start with 30 degrees. In my first triangle, I already made 30 degrees theta. And so that means the 1 is still going to be the opposite side. The root 3 is still going to be the adjacent side, and the 2 will still be the length of the hypotenuse. Using that, I can go ahead and fill in the different ratios. Sine of 30 degrees would be the opposite over the hypotenuse, so 1 over 2. If I want to look at the cosine of 30 degrees, That's the adjacent side over the hypotenuse. So root 3 divided by 2. If I wanted to look at tangent of 30 degrees, that's the opposite side divided by the adjacent. Now, if I do that, I get 1 divided by root 3. We're going to have to rationalize the denominator to simplify this one. So again, to rationalize the denominator, I need to multiply both the numerator and the denominator by root 3. If I do that, I simplify to square root 3 over 3. The other 3 functions are just the reciprocals of the first 3. Cosecant is reciprocal with sine, so the hypotenuse over the opposite. So the reciprocal of 1/2 is going to be 2. Secant is reciprocal with cosine, and so the reciprocal of cosine would be 2 over root 3. Again, I have to rationalize the denominator by multiplying numerator and denominator by root 3, and that simplifies to 2 root 3 over 3. Cotangent is reciprocal with tangent, and so when I look at the reciprocal, I want to look at the original 1 over root 3, because when I take the reciprocal of that, I'm left with just root 3, and I don't have to rationalize or simplify anything. Now, if I wanted to look at 60 degrees for each of the 3 functions, again, I want to go back to my 30, 60, 90 triangle, but now I want theta to be down here at 60. That means that now this would be the opposite side at root 3. The 1 would be the adjacent side. But notice the hypotenuse doesn't change. The hypotenuse is still going to be 2 because that's still the side opposite the right angle. So again, if I want to do sine of 60 degrees, that's opposite over hypotenuse, root 3 over 2. If I wanted to do the cosine of 60, that's the adjacent, so 1 over the hypotenuse, 2, 1/2. And if I wanted the tangent of 60, I need to take the opposite side, root 3, over the adjacent side of 1. Root 3 over 1 simplifies to just root 3. Again, I can do the reciprocals for each of the other functions. Let's next look at 45 degrees. So that will be our green triangle. Since both acute angles are 45 degrees, you can choose either one to be the theta, what we're going to use. I'm going to use this one on the left. That means this one would be my opposite side. This other one would be the adjacent. Notice opposite and adjacent are same value, which is why it doesn't matter which 45 I use. But again, the root 2 here is going to be my hypotenuse. That's opposite the right angle. Now, please pause the video and fill in the chart for 45 degrees for each of the 6 trig functions. Please now check your answers for the 45-degree triangle. Let's now see how we can use these, again, basic triangles to be able to solve for missing sides of other 30, 60, 90, and 45, 45, 90 triangles where the smallest side is not a length of 1. So, in example A, we are given that the 60-degree angle is opposite a length of 6. Now there's 2 different ways to do this. I prefer to draw out my basic triangle the exact same way that they give me the triangle I'm trying to find the missing lengths on. So again, I remember that opposite the 30 is a length of 1 on the basic, the hypotenuse is a length of 2, and opposite the 60 is a length of 3. From here, I can set up a proportion using this as my scale to solve for the missing sides. So let's start with x. If I want to find x, that side corresponds to 1. So I could do x over 1. Then I have to look at the sides that correspond that I know both lengths for. So that's the 6 and the root 3. At this point, if I just cross multiply and solve, I should be able to get my answer. So x root 3 equals 6. Remember, I want to solve for x, so I'm going to divide by root 3. But here, 6 over root 3 is not proper, so I would rationalize my denominator, giving me an x value of 6 root 3 over 3. Now when I look at this fraction, the 6 and the 3 could still simplify, giving me an x value of 2 root 3. Next, let's find the hypotenuse, y. So again, y corresponds to 2. And again, the sides that I knew that correspond both lengths for is the 6 and the root 3. Here, if I cross multiply, I have y root 3 equals 12. Following the same steps that we did when we solved for x, if you divide each side by root 3, you're going to have y equals 12 divided by root 3. You then have to rationalize the denominator to get 12 over root 3 over 3. And then simplifying the 12 over 3, I can see that y is a value of 4 root 3. Please now pause the video and try this idea for example B. Here in example B, the 8 side I was given corresponded to a side on my basic triangle of 1. And so if I wanted to solve for x, since that corresponds to the root 3 side, I could do x divided by root 3, and that would equal the 8 over 1. Cross multiplying gave me my answer right away of 8 root 3. Similar, y corresponded to 2, and so when I cross multiplied, I got y to equal 16. Let's now look at a 45-45-90. Here in example C, if I draw out my basic triangle for a 45-45-90, I can then use the same idea to solve for both x and y. So let's say I wanted to solve for x. X corresponds to a side of 1. And the two sides that I know is the 1 and the root 2 that correspond. So again, if I cross multiply, I have x root 2 equals 1. To solve for x, I need to divide each side by the root 2. But I can't leave this 1 over root 2. I have to rationalize the denominator, and that's going to give me root 2 over 2. Since y is going to be the same exact proportion, y corresponds to 1, and again the 1 I was given corresponded to the root 2, we could go through the same process and get y to be the same length of root 2 over 2. Which remember, on a 45-45-90 triangle, it's isosceles, meaning the two legs should be the same length. Please again pause the video and do example D. Here, if you draw your basic triangle the same way that the given triangle is, you'll notice that we have the exact same triangle. The hypotenuse was given to be 2, and that's what the hypotenuse is on my basic triangle. So when I did each of my proportions, I got the lengths on my basic triangle.